Hey everyone, it's Miss Grace. Today's lesson is covering reflections. A reflection is a type of transformation that uses a line that acts like a mirror with an image, so it's reflected in a line. So I know that that's a lot. We're going to talk more about all of this, but it's a type of transformation that uses a line as a mirror to reflect an image in a line. The line of reflection is the line that it's reflected over. Line of symmetry is a line that allows the figure to be mapped onto itself. The reflection theorem is a reflection that is asymmetry or isometry. And then a figure is the plane that has a line of symmetry if the figure is mapped onto itself by a reflection. And again, we're going to talk about all of these um, during this lesson and then in the next couple of days. Something when we do talk about reflections, they will give us like it's reflected over the x-axis or the y-axis or y equals x or y equals negative x. And in order to figure out where the new points are going to be, these are going to be our shortcuts. So these are going to be points that we're going to kind of want to remember because we're going to use them and reference them often when we're talking about reflection. All right, so my first example, I'm going to go ahead and graph w equals, w is negative 3, 3. So negative 3, I go over 1, 2, 3, up 3. That is point W. Now the line of reflection is the y-axis. So the y-axis is the one that goes up and down. Whenever we are dealing with straight up and down, I can do one of two things. I can either look at my shortcut, so it's reflected over the y-axis, so I'm just going to do the opposite of x and keep y the same. Or I could look at how many places over is this point to the line, because the line is going straight up and down. So I'm going to go 1, 2, 3 points to get to the y-axis, and then I'm going to go over 3 more points to be my new line or my new points. So I went over 1, 2, 3 to get to the point, or sorry, to get to the line, and then I'm going to go over 3 more. 1, 2, 3. We call this W prime. So W prime is positive 3, 3. By either doing the shortcut, because it's the y-axis, I just did the opposite of x. X was already negative, so the opposite of negative is a positive x, and the y stays the same. So either by counting over or by doing the shortcut. Looking at B, I'm going to go ahead and graph 1, 3. So we'll go over 1, up 3. This is point Z. It is reflecting over the line x equals 1. So here's x equals 1. Here's the line. This point is on the line, so the point itself is not moving. So Z prime is going to be the same point. Since the point is on the line, I'm not moving it anywhere, so Z prime and Z are the same. Looking at C, go ahead and graph 1, negative 2. So I go over 1, down 2 to get A. It is reflecting across the x-axis. X-axis is the one that goes left and right. So either you can use your shortcuts, or I can count from the point to the line of reflection since it is a straight line. So I'm going to count. I go up 1, 2 to get to the line of reflection. I'm going to go up 2 more. So A prime is going to be 1, positive 2. Looking at my shortcut, reflecting across the x-axis, the x value stays the same, the y value is just the opposite. My x value stayed the same, my y value is opposite. Opposite of negative 2 is positive 2. All right, last one. If I have B is at 3, negative 2, 3, negative 2. The line y equals 2. Y equals 2, and then I go straight across. From this point to the line, I go up 2, 3, 4. So I need to go up 4 more. So my new B point, my B prime is at 3, 6. Because this is y equals 2, there is no really shortcut. I'm just going to have to use the counting method. Something that we need to kind of make note of, y equals a number goes straight across. The y-axis goes up and down. X equals a number goes up and down. The x-axis goes straight across. If you have questions about the axis, or if y equals a number, x equals a number, let us know. All right, looking at example 2, we're just going to determine whether the shaded figure maps onto the figure of reflection. So this is actually the shaded figure. So I'm asking myself, does it map on to itself? So if I were to fold my paper in half, would this arrow map on to this arrow? And no, it would not. This is the shaded triangle. Again, I'm asking myself, if I were to fold my paper in half across that line, is that triangle going to map onto this triangle? Answer is no. And then this is my shaded. If I were to fold my paper in half, is this parallelogram going to map onto this parallelogram? It looks like it might, but it actually is not. And you're more than welcome to actually fold your papers to kind of try that, or get trace paper from us. All right, looking at example 3, if I have line AB, which is right here, and I'm going to reflect it across the line. Here's my line of reflection. It is going to map onto this line right here. So when we're doing this, our order matters. So the order of our letters matter. A comes first, so it's going to be mapping onto E. B comes second, it maps onto F. If I look at angle D, E, F, D, E to F, it is going to be mapping onto D, A, B. We already said for example A that A maps onto E. So if here's an E, it has to map onto A. If E is in the middle, A has to be in the middle. Point C is this point right here. If I were to reflect it across this line, it's going to map onto point G. Point D is on the line, so it is going to just stay D. Angle G, F, E maps onto C, B, A. Again, we already said that C and G are partners, so C and G are partners. We've already said that B and F are partners, so B and F are in the same order. And then the last one, D, G, from D to G. D is on the line, so it stays. It's first here, so it has to be first here. And then we're looking for G's partner, which is C. For example 4, we're just determining lines of symmetry. So lines of symmetry is if I were to fold this in half, it's going to line up on each other. So I have a line of symmetry straight down the middle. Again, if I were to fold on that line, this line and this line, these points are all going to map onto each other. Then I have another line of symmetry going long ways. So I have 2 lines of symmetry. For B, I have a line of symmetry that goes straight up and down. I have a line of symmetry that goes directly across. And then I have a line of symmetry that are the diagonals. So I have 1, 2, 3, 4 lines of symmetry. For this parallelogram, no matter how I were to cut it, that's not going to map onto each other. This won't map onto each other, and the diagonal will not, so this has no lines of symmetry. And then for D, an isosceles triangle only has 1 line of symmetry. All right, looking at example 5, because I don't have a graph, so I can't really do my counting method like I did on the front of the page, I'm going to use my shortcuts. So I'm going to use the front of the page where I highlighted, I'm going to be using those shortcuts. So for example A, reflected across the x-axis, t prime is going to be 3, negative 8. Again, I use my shortcut. My shortcut said x stays the same. I just do the opposite of y. Reflected across the y-axis, a prime is going to be negative 7, negative 2. My shortcut tells me I do the opposite of x. My y stays the same. Reflected across y equals x, p prime is going to be 2, 1. All I did was just flip those 2 points. And then y equals negative x. E prime is positive 2, positive 1. Equals negative x. I flip the order, and then I also make both of them opposites. All right, for example 6, whenever it says find point C on the x-axis, so AC plus BC is the minimum, we are going to use these 4 steps. First step I'm going to do is I'm going to plot my 2 points. So let's go ahead and plot A as negative 1, negative 2. I'm going to go ahead and plot B as 8, negative 4. So I'm going to go over 8, down 4. So those 2 are plotted. After I plot my original points, I'm always going to reflect A over the x-axis. This is going to work every single time. So again, x-axis is the one that goes across. Reflect it, so I'm going to count up 2 to get to the line. I'm going to count 2 more. I'm going to plug in 8 prime. After I reflect, I'm going to connect A prime to B. When we do this, try to be as straight as possible. So I'm going to just use the straight edge. And then my last step is going to be what gives me my answer. The point is going to be on the x-axis. So if I look at where the x-axis is right here, so point C, looks like it is at 2, 0. We're never going to get a decimal, or we're always going to be getting whole numbers. So that is all for today. You have homework. Go ahead and do that. If you have questions, let us know.